It's time for another Mr. Nickell's Science video.
Hey everybody, welcome back to another Mr. Nickell's Science video. I got a question for you. Would you believe me if I told you that I know magic? What if I even provided you evidence like this right here? There's an object inside this water bottle. I'm gonna make it move without even touching it. Are you ready? Watch closely. I made it go from the top to the bottom, back to the top again. I never even touched it. Now would you believe me if I told you I know magic? If you said yes, you'd be wrong. And there's a reason, because I don't know magic. I don't know magic at all, actually. But what I do know is science. And today, we're going to explore density. We're going to understand how this works, as well as why other objects can sink and float due to density and relative density. Are you ready? Here we go. All right, everybody, here we go. To understand density, first, before I explain it, I want to do a thought experiment. A thought experiment is where you run sort of an experiment in your head without actually doing it in reality. So here we go. Kind of visualize this with me as we go along. I want you to imagine if you have a chunk of a styrofoam like this. So styrofoam, obviously, when we put it in water, is it going to sink or is it going to float? So we put it in water, obviously, you probably predicted that. It's going to float. So we know that. Even if the styrofoam were gigantic, say let's try to visualize, picture a house and picture a chunk of styrofoam like this that is as big as a house, the size of an entire house. If we put that in water, what's it gonna do? If you said it's going to float, you're right. Because it's styrofoam. We know its density is low and it's gonna float on water, no matter how big it or little it is. So now let's take that exact same chunk of styrofoam that's the size of an entire house, and we get some sort of a giant hydraulic machine, some big press that squeezes that giant chunk of styrofoam that was the size of a house, and we squeeze it down until it's now this size. So it started off the size of an entire house, and the machine compressed it down until it was this big. Now what will happen if we put it in water? If you said it will sink, you're 100% right. So what changed? It was large and now it's small. So we changed its what? What's the fancy scientific word for size of something? How much space it takes up? If you said volume, you're 100% right. So we changed its volume. What else does this block have besides volume? If you said mass, you'd be 100% correct. It has mass as well, so it has mass and volume. Did we change its mass by compressing it in our thought experiment? So it's the size of a house, we squeeze it down, we shrink its volume down by a bunch, but did we change its mass in any way? No, we didn't. So we reduced its volume, did not change its mass, and all of a sudden now we put it in water and it sinks. So this is known as density. How tightly compressed things are in a specific space gives an object its density. Let me give you another example. I have two blocks here. This one right here is copper. This one right here is oak, which is a type of wood. Now, they're the exact same size, so they take up the same amount of space, so they have the same what? They have the same volume. They take up the same space, same volume, but they have the same mass? Well, there's a scale right here we could find out. All right, copper cube is 144 grams of mass. The oak cube, 7 grams of mass. All right. Okay, so we found out that the copper cube and the wood cube have much different masses. Even though they have the exact same volume, they're the same size, they take up the same amount of space, their masses are vastly different. Which tells us that there's a lot more matter crammed into this cube than there is this cube. Because remember, mass is the amount of matter that's inside of an object. There's way more matter in here than there is in here, but they're the same volume. 144 grams of mass, 7 grams of mass. So let's see which one will sink and float. Can you predict? All right, let's find out. Here we go. We'll start with the copper. Here we go. Copper, 144 grams. Oh, hope I didn't break my container. That definitely sunk, for sure, because obviously it is more dense than water. We'll talk more about that in a minute. and this is the oak. Here we go, we place it on, and it floats pretty easily. So it is less dense than the water, which brings me to my next point, relative density. So the water itself has density too. It has mass, it has volume, so it must have a specific density. So the copper, is its density greater than or less than the water that we put it in? If you said it is greater than or higher than the water's density, you're right. That's the reason that it sunk, because it is actually a greater density than the water that surrounds it. This oak cube right here, its density, is it greater than or less than the water that it's in? If you said that it is less than, and that's why it's floating, you'd be absolutely correct. It's less than the water, the density of the cube is less than the density of the water, which is why it floats. All right, that brings us back to this bad boy right here. All right, here's how this works. I call this thing the density changing machine. I'll try to do another video soon of how to make one of these. As you can see in there, there's a glass pipette. Inside the glass pipette, there is an air bubble. Now, the glass is obviously going to be more dense than the water. It wants to sink, but that air bubble inside is not allowing it to sink because of its very low density. Now, when I squeeze this water bottle, I'm going to increase the pressure of the water, which, watch what happens to the air bubble when I do that. Do you see it going up? Because I'm increasing the pressure of the water, it's increasing pressure on that air bubble and squeezing it. So remember what we talked about. If you take that matter and you squeeze it and you compress it and cause it to become closer together, you're reducing its volume, but its mass is not changing. So because of that, the density of the air bubble is actually increasing. We're also adding water to the pipette, and water is obviously more dense than air. So overall, the density of this pipette is becoming greater. So watch, when I squeeze, if I squeeze enough, you can see ml, by the way, volume is measured in milliliters. So we can see the milliliters are reducing. Smaller, smaller, smaller. Eventually we compressed it enough, the air bubble becomes dense enough, we add enough water to the pipette, and eventually it falls. Because now overall density of that pipette is now greater than water. And now when I release, it comes back up. As you can see, I can change the air bubble. More dense, less dense. More dense, less dense. If it becomes dense enough, it sinks. When I release, the air bubble re-expands, the volume increases, and now it is less dense than the water around it. All right, to wrap it up, density is a ratio between two things, mass and volume. Now, mass is what? If you said the amount of matter in an object, you'd be right. Volume is what? The amount of space an object takes up. So these two, like I said, have a specific volume and a specific mass. This one has a much greater mass than this one, but they have the same amount of volume, which makes this much more dense. There's a lot more matter packed into this than there is this. That's what gives it a greater density. And things with a greater density will do what when you put them in water? They'll sink when you put them in water. And things with a lower density than water will do what when you put them in water? Very good. So more dense than water, less dense than water. So that's what density is overall. I hope you enjoyed it. Check out my videos on rocket balloons and rad ball, because we talk a little bit about density in those as well, and there's some fun stuff you can do in those videos and do yourself at home. Be careful. Make sure you have a parental supervision when you do stuff like that. Hope you enjoyed it.